So we mentioned the extremes, and we said we have to worry about spatial variability of extremes and temporal variance, but there is also evidence that there is a spatial aggregation of the extremes, turning into widespread floods, and it's also argued in one paper that the tendency for spatial aggregation is also increasing. I will briefly take a look at what the mechanisms for spatial aggregation could be. Okay, all these are new studies. They are diagnostics. They have to be converted into model studies to reproduce the results and then look for predictability and so on. Always a challenge, but knowing the basics from observations and the diagnostics of process understanding always help with predictions, of course, which are critical for managing these situations, right? So this is from Roxy Matthew Cole's paper, which shows the trend in mean precipitation from 1961 to 2016 or so, 2015 maybe, and these negative numbers here are the regions where mean monsoon is decreasing, including over here, and there are of course these regions where it's increasing, but this horseshoe pattern appears in most studies in terms of monsoon trend. So that pattern itself has to be understood as well. But knowing that, then this is the generally what we refer to as central India region, where active break periods are defined, the extremes that we have been looking at have been defined, and so on. There is a Muslim prayer going on, so I may be hearing it a little bit. Nonetheless, we will look to see if the spatial aggregation of extremes in this box is increasing as well. So here we are looking at frequency of extreme events. The period is 1950 to 2015. This is confirming with the Goswami chapter that they are in fact increasing over time, going from less than 100 to just over 200, almost 250 here. The mean precipitation is decreased corresponding to this drop here, so that's about a 10% drop over this period, and the frequency of widespread extremes, which cover at least 10,000 square kilometers, 10-degree grid, have also increased from about 2 per year to now crossing 6 per year. Okay, each one can cost billions of dollars in losses and recovery and so on. Okay, disaster management, recovery and losses. So this is not a small thing, right? This is fairly significant. The paper by Roxy looked at this region where the floods are argued to become more widespread, going from 2 per year to 6 per year in frequency, and the range of rainfall of course is well over 100 millimeter per day in terms of the region covered with these extreme rainfall events. The mechanisms, the paper by Roxy basically looks at sources of moisture and argues that this is related to this all the instabilities we can think of. There is evidence that Cape convectively available potential energy over this central Indian region is increasing over this period, and convective inhibition energy is decreasing, which favors increased extreme rainfall and them becoming extreme as expected from the warming of the whole system and increased moisture. But the paper focused also on the source of moisture for this and argued that the contribution from the Arabian Sea is 36% for extreme rainfall over here, whereas Bay of Bengal only contributes 26%, Central Indian Ocean region contributes only 9%, and Central India recycling contributes 29%. So Arabian Sea, which is warming more rapidly than especially the Western Arabian Sea, which is warming more rapidly, is also argued to be responsible for the cyclone response over here. But as I said before, the extreme rainfall over land can be related to recycling of the previous rain, but you need a lot more moisture from external sources. So Arabian Sea, Bay of Bengal, and Central Indian Ocean contribute a lot, but Arabian Sea is dominating in terms of its contribution. Okay. Akshaya Nikumb and Arindam Chakrabarti look at the mechanisms behind large-scale aggregation of these extreme rainfall events. So we are looking here at schematics explaining the mechanism of LEREs, large-scale extreme rainfall events, the interaction of an low-pressure system that we looked at, and a secondary cyclonic vortex, which is shown here. So this is the western system and the eastern system. Remember, the LPSs are mostly coming from here. So the SEV forms, and so let me start. The interaction of an LPS and an SEV forms conditions favorable for long-lived, organized, and slow-moving convective systems on the western flank of the LPS. So on the western flank of the low-pressure system. Here we are looking at the mid-level and low-level. Remember that. Okay, that's the basic story, that you have contributions of LPS from this side and contribution from the Arabian side in terms of the secondary cyclonic vortex. The numbers here correspond to the mid-tropospheric vortex, dynamic lifting, so the instability and the dynamic lifting, deep convection are necessary, static instability, so the basic convective available potential energy or moist static instability is needed. Moisture supply is very critical, which Roxy's paper mentioned, and the organization of low-level and LPS translation speed are all involved in producing conditions that occur whenever there are widespread or large-scale extreme rainfall events. Okay, so this is a diagnostic, again, looking at a composite of large-scale rainfall, extreme rainfall events, and looking for the various conditions like the low-pressure system, dynamic lift, moist static instability, moisture supply, secondary cyclonic vortex, and the speed of the LPS itself. Something I didn't mention very clearly so far is that the active break periods are very intimately related to something called the monsoon intraseasonal oscillation, which comes from the deep tropical region into the Bay of Bengal, and then LPSs, or the active phase of the monsoon, is related to this monsoon intraseasonal oscillation. Sabir Ali's paper shows that the translation speed of the monsoon intraseasonal oscillations themselves have slowed down, potentially because of the warming. So we have to look for consistencies in terms of how a slower propagating monsoon intraseasonal oscillation, the LPS itself, and the translation speed of the LPS itself are affected. So LPS low pressure systems or monsoon depressions themselves are argued to show a trend, which I'll come back to next. So there are many pieces here. Monsoon onset, withdrawal, length of the rainy season is one thing, but there are all these things that happen within the season once the onset happens that are very critical for extreme rainfall events and their spatial aggregation. But remember again that this same team, Nikumb, Chakrabarti and others, argue that there is a increasing trend for spatial aggregation as well. Okay, so keep that in mind.